Lastly, we modeled several dynamical systems, and this is one of those systems. We tried several initial conditions for that, and we obtained corresponding behavior for each initial conditions. In this lesson, let's study in details the coding in Octave or MATLAB, how to generate such graph. For the first step, let's write a program for the system with one pair of initial conditions. If we do everything correctly, then we should get this graph. Let's write a program to simulate our dynamical system. We will code it in Octave environment, which is here, and our code will also work in MATLAB environment. For the source file, we need to choose this tab editor, and you see this will be our document, and we can save it. We can give a name. So let me call it PP for face portrait, and then demo and one. It is up to you how to call it. So you can give another name or whatever you want. Let me keep this PP demo one. Okay, so let's start. Let me start from this symbol one. Why do I start with one? Because I don't want to start with the word function. If I start with this word, then Octave will assume that this is function file, and we need to provide some input data parameters for this file. But I don't want, I don't want it. I just want to write several instructions, several commands, and then run my program. So one, this is just a symbol. If you want to check, you can press on this button. And here we can see the result. So I input one and it returned one. If you don't want to see this one and just hide it, you can put semicolon. Also, we can put comments here. So our document is script file for face portrait simulation. Now let's code our dynamical system. Our dynamical system is the following. We have differential equations. X dot 1 equals x2, x dot 2 equals minus 5x1 minus 3x2. So let's write a code for that. So this is our code for this differential equations. And if you are beginner in Octave, I recommend just recognize the input data and input parameters. Just recognize all the information. And then if you want to study it in more details, we can enough materials in the internet, in books, in other materials, and so on. So what is important here? First, matrix A, 0, 1, minus 5, and minus 3. If you take this matrix and multiply it by the column x1 and x2, you will get the right-hand side of this system. So the product of the matrix A and column X is here. Next, we need to set up the initial conditions. And let me put it as the following: 0.2 and 0.5. So when t is 0, then our x1 is 0.2 and x2 is 0.5. And we are ready to simulate our differential equations. So the comment for that is the following. And again, it may seem too complicated for the first glance, but please just recognize everything. So t is for time variable, x for our x1 and x2. So x consists of two components, x1 and x2. ODE 45. This is one of the functions to simulate the differential equations. We have ODE 113, ODE 23, and so on. It's usual if we take ODE 45. Next parameter, again, it may seem complicated, but please recognize that this part of word dx dt is here. So it is related. It is related with this function. Okay, next parameter is time ranges for our t variable. So we start from 0 when t is 0 seconds and finish when t is 5 seconds. And the last parameter is the initial conditions we set up recently. Okay, so everything is ready for computation. And if you want to see the numbers, the results in numbers, then you can erase this column. So let's launch it. Press on this and we see the numbers. So the array for t, because t must be an array, so you see it starts from 0 and ends up with 5. And also next variable x, which consists of two, x1 and x2. So each column for each variable, subvariable x1 and x2. The sizes of t, x1 and x2 must be the same. And now we need to plot a graph for our numbers, right? So we simulated our system. We have numerical values, but we want to graph it. Let's return back. Let's return our semicolon. And for graphing, we have the following function, plot. Please recognize that this parameter is for x-axis, and this parameter is for y-axis. So I mean horizontal axis and vertical axis. Then this one is responsible for index 1, so responsible for this one. This 2 is responsible for the index 2 here. Double dots mean that we take all the elements of each column. So all the elements starting from the first element and finishing by the last element. So this is the function plot. Okay, so let's see what will happen. Let's press on this, and you see we got the graph here, right? we started from this point because our initial conditions are 0.2 and 0.5, right? Then our system behaved, so it moved in this direction, right? And finally, it reached almost zero. Because our system is stable, we saw it in the previous videos, so we chose the stable system. So we start from the point 0 to 0.5 and then 10 to 0. So this is our graph. We can improve it a little bit, right? We can label the axis, we can write a title, we can also show the grid here. So let's do it and see. So this comment is for title, right? So our title will be face portrait. Then next comment is for labeling y-axis. Then let's label the x-axis and let's show a grid. So let's see what we have finally. Press and you see a little bit more beautiful picture. So this is how we simulated our differential equations, and we used one initial conditions, and finally we got the graph. Now let's simulate our system with several initial conditions. And again, if we do everything correctly, then we should get the following graph. This is our new file to simulate the dynamical system using several initial conditions. And you see now X naught is a matrix. So we need to use loop 4, and we start from 1 and finish by 8 and step by 1. So our I changes its value from 1 to 8 stepping by 1. And we still call the function ODE45. And here you see we use the indices for our X naught. So I is responsible for each row of the given matrix X naught, and then this parameter double dot, as we already know, means we take all the values in each row. Then, as usual, we call the function plot, and this operator, hold on, means we keep our graph, and when we graph a new one, then we see the old curves on the graph. And this set of comments already familiar, because this is how to improve our graph, writing a title, labeling, and put a grid. Okay, so let's launch it. Okay, you see now we have face portrait, and we see all the curves starting from those several initial conditions. So our system stable, and the motion of our system was like this. And now let me show one more function here instead of plot. It's very interesting, and I think you will like it. So instead of plot, let me use function comment. And this function comment shows a graph of the function in the motion, right? So now function plot will be set up as a comment. So Octave will not implement this instruction. And now let's see. So you see motion from each initial conditions. Okay, done. And if you want to keep the scale, so all the curves are visible in the proportional scale, then we can return back to our command window and launch the following instruction: axis, and then the ranges for our axis, for x-axis and for y-axis. Okay, let's return back to our figure. So our diagram is here. So you see, this is how it looks like now.